The Pythagorean Theorem. Our objective is to use the Pythagorean Theorem and its converse to solve problems, as well as use the Pythagorean inequalities to classify triangles. Why learn this? You can use Pythagorean Theorem to determine whether a ladder is in a safe position. Recall that Pythagorean Theorem is the formula a squared plus b squared equals c squared. It is very important to make sure that your c is your longest side of your triangle. It doesn't matter which one a or b are, but c is your hypotenuse. C is the longest side. It has to be that way. It can't be any other way. Let's look at some history. The Pythagorean Theorem is named for the Greek mathematician Pythagoras, who lived in the 16th century BCE. However, this relationship was known to earlier people such as the Babylonians, Egyptians, and Chinese. Let's practice using the Pythagorean Theorem. Keep in mind, Pythagorean Theorem is a squared plus b squared equals c squared. So our two legs, so we have 6 squared plus 4 squared equals x squared. Since x is our longest side, that's going to be our c. So now we have 52 equals x squared. We want to get x by itself, so we're going to take the square root of both sides. And for this, they wanted us to find it in this, or put our answer in simplest radical form. So we can split 52 into 4 times 13. We chose those numbers because 4 is a perfect square, which means we can then say that it's 2 square roots of 13. Let's look at a problem that's a little bit more challenging. So we have 5, x minus 1, and x. So we have 5 squared plus x minus 1 squared equals x squared. Well, we can simplify. Let's look at the left-hand side of the equation. We have 25 plus x squared minus 2x plus 1 equals x squared. If you are wondering where this came from, think of your binomial because you're squaring a binomial. This can be written as x minus 1 times x minus 1, and then you can distribute. Let's look at simplifying the side of the equation a little bit further. We can combine like terms. So we have 26 plus x squared minus 2x equals x squared. And then we can subtract 2x from both sides of the equation. So now we have 26 minus 2x equals 0. We can add our 2x to both sides. So we have 26 equals 2x, just to keep it positive. And then we can divide by 2. So we have 13 equals x. Let's look at a safety application. To prevent a ladder from shifting, safety experts recommend that the ratio of A to B, so height to length across the ground, be 4 to 1. How far from the base of the wall should you place the foot of a 10-foot ladder? Round to the nearest inch. So Pythagorean theorem is a squared plus b squared equals c squared. And we want to find a way to represent this ratio, a 4 to 1 ratio. We know what our hypotenuse is. That would be our ladder. So our hypotenuse is that c. So that's our 10. And then we need a 4 to 1 ratio. So 4x to x. Four to 1. So now we can insert that into our formula. So substituting in a, b, and c. And now we can simplify. So we have 4x squared plus x squared, which gives us 17x squared. Because remember, you're squaring the 4. So 4 squared is 16. So you have 16x squared plus 1x squared, which gives you 17x squared, and 10 squared is 100. Now you can divide both sides by 17, and then take the square root of that, which is about 2 feet and 5 inches. A set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared, is called a Pythagorean triple. Basically, no decimals. So, one of the most common Pythagorean triples is the 3, 4, 5 triangle. It appears all over the place. Other common ones would be 5, 12, and 13. Keep in mind, 13 is your hypotenuse, 5 is your hypotenuse. In this one, 8, 15, 17, 17 is your hypotenuse. In this one, 7, 24, and 25, 25 is your hypotenuse. The other two numbers are your legs. There are other ones as well. These are just 4 of the most common ones. So let's find the missing side length and then determine if the side lengths form a Pythagorean triple. Meaning when you're all done, you get all whole numbers. So we have, in this first one, we have 12 squared plus x squared, since we don't know what that is, equals our hypotenuse squared. When we simplify, we have 15 squared minus 12 squared, which will give us 81. So we have x squared equals 81. And then take the square root of both sides, so x equals 9. So therefore, yes, it is a Pythagorean triple. 12, 15, and 9 are all whole numbers. Let's try this next one. So we have 15 squared plus 9 squared equals our c squared. We don't know what our hypotenuse is. So when we do so, we end up with 306 equals c squared. So then we have the square root of 306, which ends up being 3 square roots of 34. So that is not a nice number. It's not like a 12, a 15. It's not a whole number. So therefore, no, it's not a Pythagorean triple. The converse of the Pythagorean theorem, if the sum of the two squares of the lengths of the two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So basically, if this formula happens and a squared plus b squared equals c squared, your triangle is a right triangle. If it doesn't equal c squared, it's going to either be obtuse or acute. Let's take a look at those. So you can use the side lengths to classify a triangle as acute or obtuse. The Pythagorean inequality theorem. So if c squared is greater than a squared plus b squared, you're going to have an obtuse triangle. Because remember, if it's equal, it's a right triangle. It's what you have been doing for years. Now we're taking it a step further. If c squared is greater, it's obtuse. If it's smaller, then it's acute. Let's try classifying triangles. Tell if the measures can be the side lengths of a triangle. If they can, classify the triangle as acute, obtuse, or right. So the first step you want to do is determine whether or not the numbers that were given to you can even be a triangle. Save yourself some work. So we have our two shortest sides, 8 and 11. So 8 plus 11, well, yes, that is greater than 13. So yes, it's a triangle. Now we need to classify the triangle. So you're going to take your two smaller sides, that will be your A and your B, because remember, your C is always the largest side in the triangle. Always, always, always. So you have 8 squared plus 11 squared, We are not sure whether it's equal, greater than, or less than. That's what we're trying to figure out. And then we have 13 squared. So, well, now we can start simplifying. We have 64 plus 121. Still have no idea. And then we have 169. Well, 64 and 121 together make 185. And we still have 169 on this side. 185 is larger. So, since c squared, your c squared, is smaller, your triangle is acute. So remember, if c squared is bigger, it's obtuse. If it's equal, you have your normal old school right triangle. Try these next two on your own, and then we'll try them together. Alright, now that you've had a chance to try them on your own, let's try them together. So first, determine whether or not it's a triangle. So we have 5.8 plus 9.3, and that needs to be greater than 15.6. And, well, last time I checked, 15.1 was not greater than 15.6. So therefore, it is not a triangle. Alright, well, let's try this next one. So we have 7 plus 12, and yes, that is in fact greater than 16. So we have 7 squared plus 12 squared. We are not sure whether it's going to be greater than, less than, or equal to 16 squared. So we now have 49 plus 144, which gives us 193. And 16 is 256. So therefore, our c squared is larger than our a squared plus b squared. So therefore, it is an obtuse triangle. And that concludes our lesson on the Pythagorean theorem.